In the last class, actually, we discussed about the Newton's interpolating polynomials, as well as the Newton's divided difference formula, etc. etc. So, how this divided difference formula is derived and how it can be applied or how it can be calculated, etc. we have seen. So, the divided difference formula, if we see it in a nutshell, it is like this. That is the first one. This is the simplest things, that is f x k. This is the divided difference for it's a zeroth order divided difference, and it is same as the f of x value, that is the function y of k, that is it, yk, that is the value which is the zeroth order divided difference. When it comes to first order divided difference, as we have seen, it is the difference between two, that is actually the slope, the difference between two y values, two consecutive y values, and divided by the corresponding x values. Then when it comes to the second order divided difference, it is the difference between two first order divided difference and then the difference between the x values also. Likewise, it goes up to nth order divided difference or kth order. In this case, it is kth order, or it can be up to the nth order. So x0, x1, etc. up to xn. So in that case, the difference, the divided difference is n minus 1th order divided differences is calculated. Then the difference between two consecutive n minus 1th order divided difference is found out. Then this value, that is xk minus x0 or xn minus x0. This is the nth order divided difference or kth order. In this case, it is given as kth order, or if we replace k with the n, it can be nth order divided difference also. And when it comes to Lagrange interpolation, this is actually a reformulation of the Newton's polynomial, and in this case we avoid the computation of divided differences. So here the polynomial is expressed in very simple steps or as simple notations. Two different notations are there, or two different representations are there, and using these two representations we can find out the polynomial, that is the Lagrange interpolating polynomial. So this is the first thing, that is the first relation that you have to remember. This is fn of x equal to sigma I equal to 0 to n Lix f of xi. So in this case, this n can be 0, 1, 2, etc. depending on the type of polynomial that we are preparing. So if n is equal to 1, this becomes a linear order polynomial. If n is 2, it becomes a quadratic polynomial. Then if n becomes 3, it is cubic polynomial, so and so it goes up. Normally we go for linear, quadratic as well as cubic polynomials also. Polynomials only, that is n is 1, n is 2, n is 3, etc. Only up to that much we go. So when it is f of n is 1, so f1 of x, this can be written as, this sigma symbol means I is 0 to 1 only. So this is summation. Sigma, this sigma symbol, the capital sigma, this is the capital sigma. So this means summation. Summation for I values 0 to n, integer values. So in this case n is 1, so it is I equal to 0 to 1. So this can be equal to sigma I equal to 0 to 1, then Li of x and f of xi. This is what is required. So this can be expanded as this is Li of x. So L0 of x, then f of x0 plus L1 of x, f of x1. This is the f1 of x. So in this case, f of x0 as well as f of x1 we know, that is corresponding to the y values, corresponding y values for the corresponding x values. F of x0 is the y0 value, and f of x1 is the y1 value. Now we how to find out this L0x and L1x. So for that the second representation is given, that is Li of x equal to this is the capital pi j equal to 0, j not equal to I to n, x minus xj divided by xi minus xj. So here our n is 1. So L0 of x, we have to find out L0 of x. There are two values, L0 of x as well as L1 of x. So L0 of x equal to, this is pi, then j should be equal to 0, j should not be equal to I is 0 here, should not be equal to 0, and up to n is 1. Then x minus xj divided by xi minus xj. So this is pi means multiplication, not sigma means summation. So pi means multiplication, that is we will be multiplying this time continuously. So in this case j varies from 0 to 1, but j equal to y value should be omitted, that is j equal to 0, that value we have to omit. So this j varies from only 1, there will be only one j, that is j equal to 1, because 0 we cannot consider. So this becomes x is the normal x value for which we have to find out the interpolation. So x equal to not x equal to, this is x minus x1, j here is 1, xi is x0 minus x1. So this is the value of L0 of x. So this particular value, this value can replace the value here. So this is x minus x1 divided by x0 minus x1 into f of x0. Then we have to find out L1 of x. So that is again pi of j equal to 0 to 1, but j should not be equal to 1. Here I is 1, so j should not be equal to 1. And then x minus xj divided by xi minus xj. So here I is 0, so this can be written as x, here I is 0 and here I is 1, so it can be written as x1 also. So in this case j cannot be equal to 1, j can only be 0. So here it becomes x minus x0 divided by xi is here x1 minus xj is x0. So this is the value of L1 of x. So x minus x0 divided by x1 minus x0. So that is the value of L1x. Now substituting this value of L0x as well as substituting this value of L1x, we can find out this polynomial, this entire polynomial. So this is how it is the Lagrange interpolating polynomial is calculated or found out. If it is a quadratic polynomial, then n is to be 2, n should be equal to 2. So in that case here L0x will be there, L1x will be there, and L2x will also be there. Again in that case there will be two terms here, because this j varies from 0 to 2 and j should not be equal to 0. So j can take the values 1 and 2. Here also j equal to 0 to 2, j not equal to 1. So j can take 0 as well as 2. Then in the case of L of 2, just a minute, some urgent call is coming up. Hello? Okay. Oh, staff advisors in the advisory file. അയ്യോ അതിനൊരു ചെക്ക് ലിസ്റ്റ് നമ്മൾ വെച്ചിട്ടില്ല, അങ്ങനെ ചെക്ക് ലിസ്റ്റ് ഓൾറെഡി ഉണ്ടാക്കിയിട്ടില്ല, നമ്മൾ ഉണ്ടാക്കണം. ഇവിടെ എന്തൊക്കെ കണ്ടൻസ് വേണ്ടി വരും എന്നുള്ളത് അല്ലേ? ഓക്കെ ഓക്കെ ഓക്കെ. അല്ല അത് നമുക്ക് പ്രിപ്പയർ ചെയ്യാം ഈ വീക്കിൽ തന്നെ, അല്ലെങ്കിൽ നെക്സ്റ്റ് വീക്ക്, ബൈ നെക്സ്റ്റ് വീക്ക് നമുക്ക് കുഴപ്പമില്ല. ശരി ഓക്കെ. Sorry for the disturbance, it was a call from the college, that's why I picked it up, sorry. Okay, so we can find out L2 of x in the similar way. In that case, pi j equal to 0 to 2, then j not equal to 2. So in that case, j can vary from 0 to 1. So there will be 2 times. So likewise, in the case of cubic polynomial, there will be 3 times. So it goes on. That is 1 time, 2 time. For linear, there will be only 1 time. 1 time in the sense, this is the time that I am saying, this type of time. So this is L0x. So there is L1x. There is only one variable x. X is the only unknown values here, or one variable. X1 we know, x0 we know, f of x1 we know, f of x0 we know. So the only unknown is x. So it is a function of x. F1 of x is a function of x only. So when it comes to f2 of x, that is n becomes 2, or quadratic polynomial, there will be x squared, the term of x squared will be there. When it becomes 3, there will be a term of x3, x cube will be there. Now likewise it is explained here. So for f1 of x, as we derived, it is x minus x1 divided by x0 minus x1, then f of x0 plus x minus x0 divided by x1 minus x0, f of x1, etc. Then f2 of x is x minus x1 into x minus x2 divided by x0 minus x1, x0 minus x2, f of x0, plus so on so. So okay, before going to that, to remember these things, this equation, it is very simple actually. Either you remember the previous representations, this representation, these two representation, from this one you can derive it, or the another method is, see, this term goes increasing, that is f of x0, f of x1 and f of x2. If f3 of x is, then f of x3 will be there. Then on the top, that is the numerator will be x minus x1, x minus x2, etc. So if it is quadratic, there will be only 2 times. In this case, the x is constant. X is a value which should be here. This x is the same as this x. Then x1 and x2 are subtracted from here, and you see this x0 is absent here. So if you see here, this x1 is absent on the numerator. So x minus x0 and x minus x2. If we come to the third time, then it is x minus x0 and x minus x1. So x2 is absent. So likewise, the numerator can be written easily. That is x minus x1, x minus x2, etc. And on the denominator, it is x0 minus x1 and x0 minus x2. So this is x0, and the same x0 is here also. So x0 minus x1 as well as x0 minus x2. So in the second term, here it is x1. So in the denominator, it should be x1 minus x0 and x1 minus x2. No x1 minus x1 minus x1 time will be there, because it becomes 0, and this is not defined in that case. So here in the third time, it is x2 minus x0 and x2 minus x1. So this is easy. If we go to f3 of x, in that case, here there will be another term x minus x3, and here there will be x0 minus x3. Here also the same terms will be there, x minus x3 and x1 minus x3 will be there. Here the term that will be appearing will be x minus x2 and x2 minus x3 will be there. So these are the conditions. Now if we represent it this in graphically, just for information, if we represent these terms in graphically, the first term will be like this, it will be going something like this, the first term in our previous representation, this term will be like this. Then the second term will be like this. This is for a specific case, not random values, it is a specific case. So the second term will be like this, and the third term will be like this. So in this case, x0 was 15, x1 was 20, and x2 was 25. That is why on 25 there is a point, on 20 there is another point, and 15 there is the third point. So then we sum up all these three values to get this curve. So this will be the final curve, summation of all the three terms. So in this case, this term goes through all the 3 points. This particular curve goes through all the 3 points. So this is the graphical representation of what we have seen. Now let's see how to solve problems, or how to find out or how to do interpolation using this Lagrangian method or Lagrangian interpolation procedure. So just write down this question, and we can solve it. You just write down this question. The upward velocity of a rocket is given as a function of time in the table. So this is in this table, this column is the time, and this column is the corresponding velocity. So this is represented as t, but we can take it as x values. So this is x0, this is x0, this is x1, this is x2, this is x3, x4, x5, and this is corresponding y0, y1, y2, y3, y4, y5, or f of x1, f of x2, sorry, this is f of x0, f of x0, this is f of x1, this is f of x2, and here it is f of x3, f of x4, f of x5, etc. Now this is given as t, and here it is given as v, the velocity of t, that is v of t. So instead of x we will be using t, and instead of v of f of x we will be using v of t. So now the upward velocity of a rocket is given as a function of time in the table. Now what we have to find is the velocity at a time t equal to 16 seconds using the Lagrangian method for linear interpolation, quadratic interpolation, and cubic interpolation. So if we look into this particular table, the value 16 comes somewhere here. Somewhere here 16 appears. It is between 15 and 20. So in order to go for linear interpolation, in the case of linear interpolation we use f1x, and only 2 values are required. So we consider, for linear interpolation, we consider this one as our x0, and we consider this to be our x1 because the value of x lies in between these 2 values, this 15 and 20. Our x value is 16, so, or t value in this specific example the notation is t. So in this case the t value lies between 15 and 20, that is 16 is lies in between 15 and 20. So we have to consider the 2 endpoints for the linear interpolation as 15 and 20. It is t0 or x0 is 15, and t1 or x1 is t0 or x0 is 15, and t1 or x1 is 20. Corresponding f of x0 will be 362.78. Here it is V of t0, that is 362.78. Then V of 1 or V of t1, that is 517.35. Let's see how we will be doing it. So as I said, it is a linear interpolation, so it is starting from x is 15, so this point, this is 15 and 20, so this is the second point. So this is the straight line joining this one. So and the 16 will be somewhere here. If we draw this particular curve, if you can use 16, drop a vertical line from here and here it will be 16. So this is the point. And if we are using this Lagrange interpolation procedure, we said that here it is f1 of x is required. So that is sigma I equal to 0 to 1 Li of instead of x we are using t here, Li of t and v of ti. So here it is 2 times L0 t and v t0 plus L1t and v t1. So in order to find out this one, we need t0, that is 15, and v of t0, that is 362.78, and t1 we know it is 20, and v of t1 we know it is 517.35. So we took these two values as t0 and t1 because the value for which we want to find out the velocity lies between these two time limits. If it is in some within some other time limits, then you have to go for that particular range. Now you can find out L0 of t as we described earlier, that is t minus tj divided by t0 minus tj, pi j equal to 0 to 1, j not equal to 0, that is L0 of t. So that is t minus t1 divided by t0 minus t1. L1 of t is pi j equal to 0, j not equal to 1 to 1, then t minus tj divided by t1 minus tj. So that is t minus t0 divided by t1 minus t0. So we know the value of t0, t1 as well as t, and we can substitute those values here and we can find out. So v of t, it is expanded here, so t minus t1 divided by t0 minus t1 into v of t0. Likewise, then t minus 25 divided by 15 minus 20. Since we are not substituting t here right now, because if t becomes 16, then you can substitute that value. If t becomes 17, the same equation can be used. Whatever be the value of t in between 15 and 20, you can use the same relation. So t minus 20 divided by 15 minus 20 into 362.78 plus t minus 15 divided by 20 minus 15 into 517.35. So now in our case t is equal to 16. T is 16. So we substitute t as 16 to find out the velocity. So velocity at 16 will be, if you calculate, it will be equal to 393.7 meters per second. So you just calculate it and report if there is some errors. There may be some more number of digits will be there, but just to calculate it and find out if there is some error. I can give you some 2 or 3 minutes. More than that is I think not required also. Okay. That's what I want to know. Yeah, കേൾക്കാൻ പറ്റുന്നുണ്ട്. Okay, Jenna. 393 point. Decimal difference ഉണ്ടോ? 69. Okay, 69 can be rounded off to 7. Okay. 694 എന്ന് പറയുന്നത് നമുക്ക് റൗണ്ട് ഓഫ് ചെയ്യുമ്പം 7ലേക്ക് കൊണ്ടുവരാമല്ലോ. So that is 393.7 itself. Okay, let's move on to the next thing, isn't it? So this is linear interpolation. This is the procedure for linear interpolation. This will be useful, the linear interpolation will be useful in many times, especially when you doesn't know a specific value within a specific range, like in your logarithmic charts, or in some charts where the values are given as as functions of some other independent variables. Then in that case, some values in the middle may not be available, but you need it. So in that case, you have to go for the interpolation, especially in the 7th and the 8th semester when you are doing this machine design. In that case, you will be using some tables to find out some values for the design purposes. So in that case, the intermediate values may not be available, and in that case you have to go for the interpolation procedure. So there also we go for the linear interpolation, and this is the same procedure that we follow there also. Okay, now we move on to the quadratic interpolation. In the case of quadratic interpolation, we need 3 points. Here we take t equal to 0, 10, t equal to 10, and t equal to 15, and t equal to 20. So these 3 values we take. Actually we can take the other conditions also. Actually we can, if we need 3 points, either we can take these 3 consecutive points or these 3 consecutive points. But if we go to this 3 points, there will be some answer, and if we take this answer, these 3 points, it may not be the same as the previous case. There will be slight difference, not much. There will be slight difference. There can be slight difference. But in most of the cases, if the intervals are equal, then we go for the 3 conditions, 3 points in which the x intervals are equal. So 10 to 15 and 15 to 20, the intervals are 5 each. So we can take that one. In this case, it is 15, 20 and 22.5. There the values are, the range is not, or the difference is not equal. So here it is 5, between 15 and 20 it is 5, and 20 and 22.5 it is 2.5 only. So we go for this 10, 15 and 20. So in this case our t0 is 10, t1 is 15 and t2 is 20. So these are the 3 points. The corresponding v of t values are also given. So t0 is 10, v of t0 is 227.04, t1 is 15, v of t1 is 362.78, t2 is 20 and v of t2 is 517.35. So in this case, as you know, we need L0, L1 as well as L2, because there will be 3 different terms, quadratic interpolation. So 3 different terms will be there. So L0, L1 and L2 will be there. So L0, as we have seen earlier, pi j equal to 0, j not equal to 0 to 2, then t minus tj divided by t0 minus tj. So here t minus t1 divided by t0 minus t1 into t minus t2 divided by t0 minus t2, that is L0 of t. Then L1 of t is, either you can use this one or you can directly write t minus t0 and t minus t2 divided by t1 minus t0 and t1 minus t2. So that is can be directly written also. L2 of t is t minus t0 and t minus t1 as the numerator, and then in the denominator it is t2 minus t0 and t2 minus t1. So that is L2. So L0, L1 and L2 we obtain, and then substitute it in the function. So this value either we can calculate from there itself or we can use it here also. So v0 of vt0, that value we know, then vt1, the value we know, and vt2, the value we know. So then for this case also, t1 we know, t0 know, t1 we know, and t2 we know. All the values we know except t. So in this case, the value of t can be any value between 10 and 20, because our t0 is 10 and t2 is 20. So any value, t can be any value in between 10 and 20. So here it is 16. So we substitute t as 16. Then we go for the calculation and we obtain the value was 392.19 meters per second. You just try it out whether you get the same value or not. Since it is 392.19, we can round it off to 392.2, because in the previous case we had only one decimal point. Here also we can go for only a single decimal point, so it can be 392.2. Okay, I hope you got the same answer as 392.19 or 392.2. Now we calculate the absolute relative approximate error obtained between the results from the first and second order polynomial. Which will be the closer one? The linear interpolation procedure or the quadratic polynomial? Which will result in better result in your opinion? That is whether 392 will be closer or 393 will be the closer value. So anyway, there is some relative error of 0.38 percentage. Yeah, please, which is closer? Quadratic. The quadratic polynomial will be giving you a better approximation, not the exact value but a better approximation. So that is why it is given as approximate error, not the actual error, because we doesn't know the exact value. So we are comparing with the two approximate solutions, so 392.19 and 393.70, and the percentage difference is only 3.3841 percentage. Now in the question it is given that we have to go for the cubic polynomial also. So we are going for the cubic interpolation. In the case of the third order polynomial, or also known as the cubic interpolation, v of t is sigma I equal to 0 to 3 Li t v of ta. Here we need L0, L1, L2 and L3. All these three things we need. So here we are having this 1, 2, 3 and 4. This polynomial can be used to find out the velocities between the range 10 to 22.5. So this is our T0, T1, T2 and T3. So T3 is 22.5. So here it is T0 10, T1 is 15, T2 is 22 and T3 is 22.5. So in this case we doesn't go to any point below the 10, the value 10. Instead we go to a higher value, because since we know the value of t, that is 16, we go to 2 points below and 2 points above that one. So here L0t is with this relation you can find out, or using directly also you can write t minus t1, t minus t2, t minus t3, then divided by t0 minus t1, t0 minus t2, t0 minus t3. L1t, t minus t0, t minus t2, t minus t3, divided by t1 minus t0, t1 minus t2, t1 minus t3. L2 of t is t minus t0, t minus t1, t minus t3 divided by t2 minus t0, t2 minus t1 and t2 minus t3. L3 of t is t minus t0, t minus t1, t minus t2, t3 minus t0, t3 minus t1 and t3 minus t2. So using these functions, we can find out the value of L0, L1 and L1, L2 and L3. Then we substitute that values in the polynomial. So here it is v of 16. T is 16, t1 is 15, t0 is 10 and t2 is 20 and t3 is 22.5. v of t1, that is the y value corresponding to t0, the y value, then etc. we go to here. Some time actually, okay, there are some errors here. This should be v of t0 and this should be v of t1. This is not this one, v of t0, and this should be v of t1. So there is some typing mistake there. So this is v of t2 and this is v of t3. Now you can calculate the value and you will get the value as 392.06 meters per second. Are you getting the same value? Just try it out. Okay, I hope you obtained the result. If any variation is there, just inform me. Is there any variation or this is the same value, that is 392.06 or somewhere on that range, 392.1, within that range. Okay, now we find out the absolute relative approximate error, epsilon a, obtained between the results from the first and second order polynomial. Between the this is not first and second order, this is the second and third order polynomial. Sorry for the mistake. This is not the first, this is second and third. Between the first and second order polynomial it was some 0.3%, and between the second and third order polynomial it is some 0.03% difference. So likewise we can go up, we can go for the fourth order polynomial. So in that case the difference will be again very small fraction, or we can go to this fifth order polynomial. That will be very much closer to the actual value, fifth order polynomial. More than that it is not possible with this data, because we have only 6 points with us, 1, 2, 3, 4, 5 and 6, only 6 points with us, and hence we can go to up to fifth order polynomial. More than that it is not possible, but normally we go for only up to cubic interpolation. If we need more closer values, then only we go for more than that. Okay, I hope you understood, and if any doubts are there, we can just discuss it. The next is actually there is a comparison table between first order we got the answer as 393.69, and for the second order polynomial we got it as 392.19, and third order we got it as 392.06. So then absolute relative approximator is 0.38% and 0.03%. So as the order of the polynomial increases, the value becomes closer to the actual value. That is the representation. Now the next one is Eichmann interpolation, and we will discuss it in the next class.